Today we'll be talking about Ntopng. This is going to be a technical webinar. Just to introduce the topic to those that are not super familiar with the tool, and to those that are using it but want to know more about the latest news about Ntopng 6.4 that we have released in May. In 2 weeks, we'll show another webinar about NDPI that is a toolkit used for deep packet inspection. I'm going to talk about that in a few minutes. And as you have done today, you have to register. You go to blog.ntop.org for details, and we'll be talking about this topic. Let's start with Ntopng. What is Ntopng? Ntop is the company name and was the original product that I started to develop about 25 years ago. The idea of Ntop was to show to users what was happening on a network. And because the main problem at that time was the lack of bandwidth, the network were very slow. The main problem was to understand who were the top users, the top heavy users of a network. Therefore, the name N stands for network and top users. Over time, the original design of Ntop was no longer modern. First of all, because networks changed a lot. Especially 25 years ago, we had IP and non-IP networks. Today, basically everything is IP, IPv4 or IPv6, but non-IP protocols are very limited to specific market segments or to specific devices, such as industrial automation. So therefore, the application had to be redesigned. Since then, it is named Ntopng, Ntop Next Generation. What is Ntopng? It's a web-based application that provides you network visibility. So that allows you to see what is happening on a network. And because today, most of the protocols are limited to a few based on QUIC or TLS, the problem was that it was important to provide visibility. Because of that, we have created a toolkit named NDPI that is doing the packet inspection that I will be talking later. In essence, in Ntopng, you see a web interface. It looks like a web server, but you're monitoring the network. So Ntopng observes what is happening on a network, consolidates the data in memory, and displays you that through a web interface, similar to a website. Pages are static, okay? So they are created based on content, but users basically navigate Ntopng as if it was a website. At the end of my presentation, I'm going to show you a demo just to show you how the system is working. It is available for various platforms, included Linux, macOS, Windows, and the various FreeBSD flavors, including OpenSense and pfSense, and of course Docker. The two main architectures we support is Intel and ARM, but it runs on many other platforms. For instance, embedded platforms such as MIPS is not a problem. The idea of Ntopng is to process packets. So therefore, for every packet, Ntopng has to update statistics, has to do many things, and the performance is limited to about 25 gigabit per second, or if you have a flow collection, to 100 gigabit per second or more, where preprocessing happens on the probe. If you want to monitor fast networks, therefore, we suggest you to combine Ntopng with a so-called flow processor that I'm going to talk in a second. Whereas if you want to sniff packets directly out of a network adapter, the average speed you can expect with modern architecture is about 25 gigabit per second. What is the packet inspection? It's one of the pillars of our tools, because the packet inspection is a technique that allows you to inspect the packet payload, namely the packet content, so what is passing inside the traffic, and not just limiting our visibility to network header. The packet inspection, it is interesting, but many times people say, okay, but what can you do when most of the traffic, and today we are about 80%, is encrypted? This is a good question, but at the same time, doesn't mean that we are unable to understand or to evaluate the traffic when traffic is encrypted. Simply because in encryption, the initial part of the network traffic is unclear. So in essence, there is an initial negotiation where the two peers exchange meaningful information. So for instance, when you want to access Google Maps, a client tells to Google that I want to talk with Google Maps, I don't want to talk with Google Mail. This means that it's possible to infer the website or the usage of a certain flow looking at the initial few bytes. And this said, it is important also to understand that we have to be efficient, because contrary to 25 years ago, and 1 gigabit was already high speed, so today 10 gigabit is common on servers, and on data center you have 100 gigabit or more. So therefore, these DPI libraries have to be efficient. We have designed NDPI to be efficient. As I've said at the beginning of this webinar, in 2 weeks, I'm going to go deep into the library. So for today, just imagine that it's a toolkit, open source toolkit, same as Ntopng, that allows you to classify about 440 protocols. It's easy configurable, so it means that you can configure new protocols simply adding a new configuration file. So let's say if you want to define the CNN protocol, simply add a line, a config line saying whatever goes to cnn.com, this has to be called CNN as a protocol. It is also designed for cybersecurity, because today many people have to face with this challenge. So therefore, Ntopng and NDPI are able to display something called flow risk. So basically problems that are basically inside the traffic, simply because somebody is trying to circumvent security using some tricks, or because the traffic is not perfect. For instance, the TLS certificate is broken or it's outdated. So in essence, we are combining visibility of NDPI with the ability of inspecting cybersecurity threats and reporting this to the user. On top of this, Ntopng is also based on another toolkit that we have developed that is also open source, called PFring. PFring is designed for Linux systems. So on non-Linux system, we rely on the operating system, but on Linux, that is our main platform, we use this tool called PFring. We have the ability of accelerating packet capture. Accelerating means make packet capture more efficient. It also means that we are able to shuffle traffic in a way that makes it easier for Ntopng or for other tools to monitor. Let's make an example. Suppose that you want to wiretap a network. So you install a network tap and you divide the traffic in two directions, Rx and Tx, and you need to combine them before analysis. Or suppose that you have asymmetric traffic, or you suppose that you have Rx traffic on a VLAN, Tx traffic on another VLAN. So these are typical examples where you need to reconcile the traffic before analysis, otherwise analysis will be partial. So in addition to speed, PFring allows you to do all this, allows you to reach 100 gigabit and more of performance while being able to consolidate the traffic for network analysis. So at the moment, the PFring is available in two flavors: the standard Linux kernel module that works with all network adapters, and the zero-copy module called PFring ZC to bypass completely the Linux kernel and therefore to improve the performance of application at 100 gigabit or more. This is available for selected network adapters that are Intel or NVIDIA Mellanox, as well as some FPGA-based cards. So just to summarize, the Ntop ecosystem is composed of various components. All of them are sitting on top of PFring and NDPI, okay? And we have Ntopng, that is the topic of the day, that is at the top. Ntopng can analyze traffic out of a mirror port or a span port, and can receive directly packets. As I've said, the performance is limited to about 25 gigabit per second. But if you want to go faster, you need a preprocessor. So that is called, in our case, Nprobe or Nprobe Central for 100 gigabit networks. This preprocessor allows you to collect flows sent by a router or by a switch, such as IPFix, SFlow, and so on, or to import something called logs, flow logs, generated by cloud providers such as, for instance, AWS or Google, transform them into flows, and those flows are sent to Ntopng. With flows, Ntop can scale above 100 gigabit, simply because part of the work is performed here on this preprocessor. In addition to traffic analysis that I've said before is available through a web GUI, it is also possible to dump traffic to this for later analysis. Imagine what you do with cameras, security cameras on a building. The same happens here. So with N2Disk, it is possible to dump the traffic to disk, I mean pickups, okay? And whenever something bad happens, or whenever there is an event, so you can go back in time and can extract the packets that have created the event. This is very important for security, for instance, or for other critical environments such as bank, this type of places where you don't want only receive an alert, but also go back in time and try to understand the genesis of the information. And this is the Ntop ecosystem. We have other components, but I don't want to put too many on the table today just to avoid confusing you. What can Ntop can do for you? So first of all, network visibility. This was the original goal. I told you this at the very beginning. So we want to show you what is happening on a network at a host level, protocol level, autonomous system, just to have an idea what is happening on your network. Recently, we have added key performance indicators, but in particular, we have that QoE. So it means that we not only tell you how much traffic, but how good was this traffic in terms of quality. Just to give an example, is this webinar, playing correctly or not from the network standpoint? Is there a problem with delay, with excessive packet drops, or any other type of problems that can affect the quality of experience? So the case of multimedia, for instance, the streaming, or in case of SSH, how fast you can type on your keyboard without waiting the screen to show you what you have put on the keyboard, or other type of protocols such as, for instance, network download. So how fast is the network download? Is it constant download, or is somehow not perfect because it's accelerating and reducing the speed, something like that? This is called QoE. And Ntopng also can show you misconfiguration and misuse. So it means that it can report you those situations where a user can improve the network simply because there are some mistakes during design, or because over time some devices have been added in a non-perfect way, or simply because somebody has injected some traffic that was not supposed to be on a network. As I've said before, we can show you cybersecurity information, show you, for instance, dangerous or insecure traffic. So for instance, show you when users are using old-fashioned protocols where credentials are unclear, just to give you an idea, or if there are some intruders on your network, some application or some host that are performing, or injecting traffic that is not supposed to be on a healthy network. And for that, we are able to do this passively. So meaning we check the traffic, we try to understand if there is something bad happening, or actively. So for instance, in this case, through Nmap. So when we do vulnerability scanning, trying to figure out whether there is something outdated on a network, and to understand whether some machines need to be improved from the security standpoint. Recently, we have added network inventory. That means that we classify the assets. We keep a list of the assets that we have observed passively on a network. And this is very important. I'm talking about as European, because there is a new directive from the European Union called NIS2 that basically obliges big companies and selected companies that are doing specific businesses to keep track of that. So Ntopng can very well be used for that. So to understand when there is some changes on a network, when a new device has been added, or when a certain device is active on a network and doing certain activities. And this is very important. And of course, we combine this with SNMP. SNMP is the typical protocol for device monitoring that allows you to understand what is happening on a network and combine this with traffic visibility. So who can use Ntopng? Certainly, one of our main users is SMEs. So basically, small and medium enterprises that need a tool that allows them to see what is happening on a network, not to mention home users. We have large enterprises that are using Ntopng to consolidate on a single view something that is distributed on a network. So we install probes, at the various network edges and send data to Ntopng that shows you that on a user interface. Other users that we have are managed service providers that are using something we call floating license or license management that allows you to consolidate on a place those licenses that can be used by users on demand. So it means that you can have users that require the service for some time, and then they unsubscribe from the service. and this is supported by our tools. We also support internet service providers that we can, for instance, report information about content delivery network, autonomous system, how the traffic is flowing on a network, what routers, what interfaces are mostly used, things like that. And of course, as I've said, we support small companies. This is where our roots. Companies that have a limited budget, but they have very modern equipment that allows them to have complete visibility through our tools. We have various licenses. Okay, being an open source product, we have the so-called community edition that allows you to do most of the things I'm going to show you today in a demo, but limited in terms of, for instance, number of flows. A flow is a communication that is happening on network or number of monitored hosts. And then we have other type of licenses, Pro or Enterprise, various flavors, that in essence are increasing new features on top of the existing community license, but that allow you basically to do more with Ntopng and to go deeper, analyzing, for instance, more in detail and network traffic flows and cybersecurity threats. Of course, when you need to scale up, you need to exploit the hardware. You have to know your network a little bit. And Ntopng can exploit that. So we are trying to simplify this with a very few commands. When you start Ntopng, in essence, what you have to do, you have to specify a network interface with -i that says that Ntopng is reading traffic from this network interface, in this case using MPF ring 0 copy, or in the other case, you can specify standard interfaces without PF ring, and you can say whether you want to sniff from a single interface or whether you want to combine the traffic from two interfaces. This is probably a good example for a network tap. For instance, you want to merge the traffic first and then to display everything on a single view. So it means that everything is displayed and consolidated together, okay, regardless of the fact that it's being sniffed from two interfaces. And of course, you can do the same. RSS is a technology that allows you to scale up, in particular for high speed. And in this case, you can instruct Ntopng to capture from various sub-interfaces, and at the end to combine everything on a single view interface. I'm going to show that in a demo. Before I said that Ntopng allows you to scale up using flow processing, I was meaning this. So Mprobe is our tool, okay, part of the Ntop toolkit that allows you to collect flows from various devices, such as a Cisco router, a MikroTik, or a VMware, and to consolidate them into flows and send flows to consumers. One of them can be Ntopng, or you can send it to Kafka, to Elastic, or to a database. And of course, Mprobe can also read packet from a network adapter. Because Mprobe is preprocessing traffic, Mprobe allows to improve the performance of Ntopng, in particular the Ntopng on high-speed networks, simply because Mprobe is preprocessing the traffic, is extracting DPI information, and is sending that preprocessed to Ntopng that has less workload, because most of the work has been done here. And depending on the speed, there are two flavors, Mprobe up to 10 gigabit, or Mprobe Cento, that's a different version, up to 100 gigabits. And these two tools can be combined with Ntopng. In essence, with Mprobe, you have a flexible way of collecting data, as I've said before, coming, for instance, from cloud providers, coming from SFlow, NetFlow, or IPFix, or coming from other source of data or from packets, if you wish, and then to send them to Ntopng. The syntax you have to use is very simple. So in essence, you tell Ntopng to capture traffic from a TCP socket, okay? And in this case, you tell Mprobe to analyze traffic, for instance, from a network interface to send data onto the same TCP socket. And then Ntopng and Mprobe can communicate. In this example, I put the two applications on the same machine, but you can put them remotely. So it means you can have, let's say, Ntopng on a central location and various Mprobes at the edge of the network. So therefore, you don't have to send packets to the center, but you have to send flows. And flows are a very consolidated view and a smaller view in terms of volume with respect to packets, but that guarantee you the same type of visibility. In terms of data storage, Ntopng uses a few backends. We require Redis as a local cache to store temporary data. Ntopng out of the box embeds a database based on SQLite that is used to store configuration information, alerts, and things, let's say, on a limited network site. If you have a larger network, we encourage you to run Ntopng with the ClickHouse. ClickHouse is an OLAP database, so basically it is designed for analytical analysis. And it's very efficient because as of today, it is able to store in the current version about from 80,000 to 100,000 flows per second, but later I will show you that we are working at a higher speed. And ClickHouse allows you to have long-term visibility because in addition to real-time visibility, it shows you also historical data. And it's very fast. We have other two types of databases that are supported, round-robin database and InfluxDB that are used for network time series, so basically for depicting charts of the network. And of course, you can consolidate everything on the popular Grafana tool. Before jumping to a demo, I want to give you a quick hint of how Ntopng works. So in essence, you will see a web interface. On the top of the web interface, you will see a drop-down menu. This drop-down menu allows you to move from one network interface to another in case you have multiple interfaces. Here you have a chart that displays in real time, because Ntopng is a real-time traffic monitoring application, the live throughput of the network, so dividing uplink and downlink. At the top of the screen, you have something called host and flow overview that allows you to have an idea of what is happening on the network. In this case, here with green, you will see you have 4,300 local hosts talking to 132,000 remote hosts and over 1.2 million flows. So this is the typical numbers that you can see here on the network, just to have a better view of what is happening on your network. And on the left side here, you will have in real time the alerts. You can see, for instance, that we have 81 hosts that are alerted. So this it looks like a high number, but it's not that high when you are on the internet without protection. This is a service provider. And here you have the number of flows, 35,000 that have, let's say, network problems, and the 152,000 have warnings. And here is the main. This is the main view. This is the main page of Ntopng that allows you to see what is happening on the network very quickly. And because it's a web based interface, you can click anywhere on the page. It can go deep and to see what is happening at host level or flow level. So for instance, this is a flow, that is a communication between two peers. You will see that here at the top, we are displaying information about, for instance, the certificate. This is something called ETA, Encrypted Traffic Analysis. We carefully analyze what is happening on this communication. We report you data that is not supposed to be good. And for that, we have a numerical indicator called cybersecurity score. The higher is the score, the more relevant is the problem. And when the score is above 100, it's a severe problem. Those numbers combined together allows you to evaluate a certain communication, whether it's good or it's bad. And these are very important for cybersecurity. In addition to that, we have added something called fingerprinting. Fingerprinting it's a numerical value or a hash value, depends on the protocol, that allows you to infer the type of the traffic that is flowing, or that allows you to create a unique identifier of the traffic, so that you can recognize this traffic when it's sent in big volume on a large network. This is very important for spotting, for instance, cybersecurity threats, or for instance, for detecting the operating system. In the last few months, we have spent a lot of time with performance. At the moment, we have released 6.4 stable, but we are working already at 6.5. As you can see, we are trying to squeeze the performance and as well the memory. So just to give an example, this is a network we used to have a 6.3 that we're using almost 6 GB of RAM. On 6.5, we are less than a gigabyte. So we are trying to improve the performance at the same time to reduce the number of resources. At the same time, we are now trying to push the performance even further. For instance, improving the performance of ClickHouse from 100,000 flows per second to more than that. We are making tests. At the moment, we are able to do at least double the performance, but this is something ongoing. At the same time, we also want to improve the query performance so that you can query a million or billion of entries very quickly in a matter of a few seconds. So I'm now going to show you a quick demo of the tool, just to give you an idea of what Ntopng can do for you, before passing to Matteo, that is going to show you instead the news of Ntopng 6.4. This is how it looks in Ntopng. So here at the top of your screen, you have the menu, the drop-down menu I was talking before, with the network interfaces that are capturing traffic. At the moment here, I'm monitoring myself. So in essence, I'm monitoring my PC with the webinar. As you can see, thanks to the packet inspection, it is possible to understand, who's using the network. So in this case, it's me. This is a Teams call, of course, and this is the video stream, and this is the audio stream. Even though it's encrypted, I'm unable to understand what is happening. But at the same time, Ntopng, it is able to say, okay, this traffic, okay, is created by the video, this is by the audio, and this one's by the desktop sharing. So it means that I'm sharing now my desktop with Teams. And so it's possible to carefully identify and precisely identify the type of traffic, even though it's encrypted. Here you can see DPI, so it means that NDPI has performed the traffic analysis. And when you click here, you can see other indicators that allows you, for instance, to detect more about this traffic, okay? So in this case, for instance, it's a Zoom call, there is nothing much to see, but the important thing is that it's a video stream. When you go back here, you can specify what type of application you want to monitor. So for instance, take DNS. And for every request, it's precisely indicated what type of request is done, okay? And the same for other type of protocols, for instance, for Dropbox or other type of protocols. And this is something called flows. So this is the interface, these are the flows. In addition to flows, then you have the concept of host. And hosts are the peers that are talking together, okay? So in this case, let's take this host, for instance. This is one host that is from Microsoft, that is probably one of the peers with whom I'm talking to. Yes, in fact, it's the Teams traffic. And for every host, you can create a chart of, let's say like this, of packet distribution, parts use. Okay, this host has expired. Let's take another one, because in Ntopng, when the traffic is over, so both the flow and the host expires. So let's take this flow, for instance. And as I've said, there are the two peers. Let's take my PC. So as you can see through the fingerprinting, okay, it's possible to identify the operating system. It's a macOS, of course. And it's possible to also to figure out with whom is talking to, with how many services, the various names, okay, that have been learned on the network, and the operating system that has been inferred through through NDPI fingerprinting. It's possible also to identify the list of MAC addresses on my network, and of course something called asset inventory. Asset inventory is the ability to keep track of the assets on a network and to understand who is doing what, okay, and also to figure out what type of operating system or services a certain host is doing. So for instance, this is my laptop that is not in use at the moment. I can learn exactly the model because they are exporting this data, and can keep this consolidated in a database. You can receive an alert when a host is connected to the network or when a host is leaving the network. Of course, you have maps of the network. Okay, you have also geographical maps. So that's typical. Okay, let's use of hosts where they are connected to your networks. And you also have the ability of configuring something called traffic rules, so access control list, and Matteo is going to show you in a second. So there are many features that you can see. The last one I want to show you is about alerts. Okay, when you have an alert, you can specify, so for instance, the policies. So we have here the ability of specifying behavioral policies that allows you to trigger an alert when something bad happens. And when there is an alert, you can receive a notification. And those notifications can be sent through various means. Okay, so for instance, a webhook, a Telegram, email, or anything. And this one allows you to understand what is happening on a network and to receive a remote communication when something is wrong with your network. Of course, you can create beautiful dashboards. Okay, this is an example of a dashboard based on historical data that you can find on a network. There are many other things I would like to tell you, but I don't want to go too deep in particular because I don't want to take all of your time. I would like to let my colleague Matteo to show you the news about Ntopng 6.4. And then at the end of his presentation, I would like to accept some questions. So if you have questions about the tool, so that we can hear and answer your question. Matteo, I leave you the screen.
Yes, can you hear me?
Yes, go ahead.
Okay, good. Let me share. Okay, you should be able to see the slides, right?
Yes.
Okay, great. Thanks, Luca, for the introduction about Ntopng. Hello, everyone. Now let's take a look at the Ntopng 6.4 version. Like Luca introduced already before, Ntopng 6.4 version was released more or less 1 month ago. And let's take a look at the news. Now, before starting, a small introduction. This time, in the Ntopng 6.4 version, what we wanted to achieve was not just adding more data to Ntopng, because for those who are familiar with Ntopng should know that a lot of information are stored in Ntopng. Pretty much every information, even you can grab from packets, for example, can be visible in Ntopng and gathered by Ntopng. What we wanted to achieve this time with this last version, we wanted to achieve a better visualization of the data. Okay, so we didn't stop obviously to add more data, more new data, let's say, to the one that Ntopng stores, but we wanted to enhance the visualization. Now let's take a look at what do I mean by enhancing the visualization. An example that Luca already introduced is the asset inventory. Okay, with this simple feature, what we wanted to achieve, we wanted to simply answer a really easy question, which are my local hosts, okay, or which are my services in the network. Well, that was already possible in the previous version of Ntopng. Obviously, you could get all those information, but you couldn't get all of those information together. Previously, you could get the active localhost from one page. You could get all the hosts contacted locally from the historical, for instance, but you didn't have the possibility of having a single page where all the local hosts, online, offline, so active or non-active, were gathered. This is, for instance, the dashboard about the asset. So we can already see some feature about some information about this new feature. For instance, here we can already understand which are our assets inside our network. For instance, we can see that we have in our network 1.2K HTTP or HTTPS servers. And the total of active assets in the network is around 4K. Now, obviously, other than the dashboard that it's flashy and well visible, we have even the table version. Obviously, if you want to drill down, the table is always the nice feature. So let's take a look at the information we have. We have, for instance, here the possibility to see if an asset is currently online or offline. And in case, we could gather even the information about when was the last time it was online. This could be really useful because sometimes you could have in your network some hosts that local hosts that shouldn't be connected, and why are they connected? And when was the last time that they connected to the network? Well, you can answer this simple question by using this new feature. Obviously, Then we can even drill down to the asset we have, and drill down and gather more information about this simple host, not just the first and last scene of the host, but even which services does it provide. So, for example, this host provides a DNS SMTP server, so provides a few services, and even which port were recontacted to as a server, obviously, because we are talking about assets, so services. Services should be contacted as a server. Now, jumping from the visualization of the hosts to another pretty important metric, we thought, that is the quality of experience. The quality of experience answers a simple question, okay? How is the quality of the flow? For instance, we are currently in a Teams call. How is, however, the quality of the current active Teams call? Well, to check that, it's not that easy, but in Ntopng, we already had all the metrics, all the information that we could use to achieve the quality of experience. So we decided to combine those information, just like the RTT, the jitter, the retransmission, packets out of order, these kinds of information, and to achieve the quality of experience. So as you can see here, for instance, we can see that there are some flows that are good and some instead that are bad. However, how can we understand what is bad in a flow? Well, when we drill down inside a flow, we can find, for instance, here you see an example. From the client to the server side, the quality of experience is excellent. So 100%, everything is good. However, we have a problem. We have a problem from the server to the client side. And which is this problem? Well, as you can see from the red one, it is the retransmission. As you can see, there are 31 packets retransmitted from the server to the client. You can easily understand that with 174 packets exchanged from the server towards the clients, if 31 packets are retransmitted, there is probably some kind of issue inside the network. Now, another kind of visualization that a lot of customers asked us is the possibility to have multiple Ntopng instances, because like Luca introduced before, obviously Ntopng has limits. And sometimes there are some customers that are asking us, okay, I want to go over these limits. I want to have multiple Ntopng instances and be able to access the dashboard, for instance, of these different Ntopng instances. With this new release, it is now possible to have a centralized infrastructure dashboard, we call that, where it is possible to monitor all the Ntopng instances. Then, if you want instead to drill down into a problem, so, okay, I have a lot of alerts, I have a lot of traffic in this specific Ntopng instance, then you drill down to that specific instance of Ntopng and you find the problem, and you search and find for the problem. So this is the idea, having a centralized point, a centralized Ntopng, where you gather, as you can see again from this picture, where you gather the information about the different instances you have. For instance, here from the picture, we can have a pretty idea of the architecture. So we have currently a total of 3 instances, okay? 2 of these are currently active and 1 is inactive, okay, offline instance. You can get the total hosts that are visible from the available active instances, the alerts, the flows, sorry, and the chart about the traffic. Also, you can get other information about the instances, as you can see from these small widgets, small tables we have here in the picture. So we simply jump to an Ntopng instance, okay, where from this infrastructure monitoring, we add all the Ntopng, all the various Ntopng instances we want to monitor. For instance, I configured these 3 instances, and in this way we are able to achieve the infrastructure dashboard I was showing you before. Then, like I already told you, if you want to drill down into a specific instance, you simply click on the instance, click on the host, and you go and find and search and find for the problem you want to search. Also, again, from the visualization point of view, if you remember in the 6.2 version, we developed the possibility to create your own reports, to create your visualization of the historical data. Okay, if you remember, we have let me directly jump. Okay, the possibility to create here by clicking this button to create a custom report, get all the widgets, so all these charts, tables, and so on, in a single page, and create, like I was saying, your report. We try to enhance this feature by adding even more default reports. Previously, in the 6.2 version, we just had the simple default, let's call it, report. Now we enhanced the reports with a lot of already created reports that we think that can help understand the structure of the network and if everything is going well or not. We also have some news about SNMP. If you remember, in Ntopng we support both SNMP v1, v2c, and v3. And lastly, in the last couple of months, support to SNMP v3 context, and the support to various authentication protocols and privacy protocols that previously were not available. Other than SNMP, we also enhanced the network configuration. Okay, like I was saying, we were trying with the last version of Ntopng to have a better visualization. Okay, this stands from even the network configuration point of view. We all know that whenever we analyze a network, we have, for instance, servers, so like DNS and TP servers inside our network. So how can we find instead if someone that shouldn't be contacted, for instance, with a DNS protocol is contacted? Well, previously there were alerts. Now we enhanced these alerts by adding a single standalone dashboard where you can configure your specific DNS server and TP server and so on and so on. And whenever a new host is seen and detected as that asset, we go back to the asset idea, Ntopng is going to trigger an alert. Also, we are talking about restricting hosts. Also, we decided to add the network policies. This is a pretty interesting topic, I think, because in a network, we all know that there are some services, there are some core hosts, like router switches. And we know that, for instance, a restricted host shouldn't talk with, so a server, for instance, a VPN server, shouldn't talk with all the routers, all the switches, or all the hosts inside your network, or even worse, outside your network. At the same time, you know that your core host shouldn't talk, for instance, as a client, I'm talking, with the host in your local network, but should be contacted, so should act like a servers. This is the idea of the network policies. So to understand if there is some connection inside your network that shouldn't be there. So already introduced the alerts idea. In the Ntopng 6.4 version, we also enhanced the alerts. We reworked a lot of alerts because we thought they were not that well designed. So we decided to rework, for instance, the scan alerts. We decided to enhance those alerts with more precise data and have a lot lesser false positive. Also, again, still talking about the alerts, we developed a map, like Luca already showed in the webinar at the start. We also added a map that is possible to visualize as a graph the hosts that are that triggered an alert, or at least that are part of an alert, and so be able to see all the hosts that are causing some problem. Also, it is possible to filter the data by using obviously the filters available in the historical page, in the historical flows. So the filters are pretty much available, so you can drill down and find possibly the problem. Now, let's talk instead about the fingerprint. The fingerprint is a technique used for labeling data. Luca already introduced this concept, and there are, for instance, a couple of ideas of fingerprint. For instance, you have the browser fingerprint used to collect information about the device, the browser, and so on and so on. Otherwise, you can use the fingerprint as a policy enforcement. So you know that specific fingerprints should be on specific VLANs. So if you find another fingerprint on that VLAN, that is a problem. Also, fingerprint can be used to detect hidden devices. So we decided to integrate all these features and visualization inside Ntopng. For instance, now, thanks to the NDPI support about fingerprint, we are also able to identify better the operative systems of a host. Or we can print, for instance, the fingerprint detected in the TCP. Lastly, last but not least, we have even some user interface improvements. We are still working on reworking the whole Ntopng web interface and moving all the pages to the Vue.js framework to have better pages and even more faster pages. But not only that, we know that there is a problem sometimes when opening the web interface, because Ntopng sometimes load pretty high amount of data to visualize all the pages. Currently, we were able to reduce the size of this bundle, let's call those bundles, loaded by the web interface. And we are currently working on reducing those bundles furthermore from some tests, it seems that they should be enough. We should be able to reduce the size by more than half. So from 4.7 megabyte to goes to 2 megabyte, more or less. Okay, thanks for listening, everyone. Please, if you have any question, please ask them.
Matteo, yes, there are some questions in the chat that we need to answer. I don't know if somebody has questions to want to ask live, or if we have to go through the list in the chat. Anybody wants to unmute and ask us questions? Okay, no.
Hi.
Questions? Hi, please go ahead.
Okay, thanks. Well, I'm Xavi from UIB, University at Mallorca. And we, some weeks ago, we updated everything. It's true that we updated our network devices too. And I think we faced some problems with licenses. Maybe I'm sharing with you an image on the chat. We usually send S-flow information from our distribution point. So there were a few ports in its distribution point, but I think it was on the slide number 9 of the previous presentation. You were talking about some kind of licensing types, yes. And I think that I don't know if it's new or if it's that we have changed our devices and now we have to monitor at the access level, and now we have a lot of ports monitoring. Do we understand it correctly when we say that in this image we see that we can monitor from 512 ports, not more? Because in slide 9 you were talking about how many flow exporters and
yes.
this, and is it true that we understand that there's a limitation with the ports that can be monitored?
Yes, based on the license type, okay, there are some limitations. No, I don't know exactly what license you're using, but it looks to me that you're below the limit, so everything is good. I tell you why we have introduced those limits, because in the past we have spent a lot of time supporting people that were injecting everything into a single instance simply because they wanted to do the easiest thing, okay, send everything into one place, and the performance was poor. Okay, so therefore we had decided to tell people, hey, try to split this, to partition the workload, don't send everything to one place. Of course, if you're willing to pay more, but I think for universities, you know, everything is free in your case. If you want to pay more and you want, because you're lazy, you don't want to distribute the workload, okay, we can offer you a more expensive version. But in practice, the idea is to partition the workload. But according to this picture, everything looks good to me. So
yes, we opted to set up different instances for different buildings, so we don't hit the top of ports. The question was just to confirm that now we are facing that port limitation. It was just this, and now everything works fine as long as we use different instances for different buildings. It's okay. We don't hit this limit.
But if you want, we can give you a more capable version. That's not a problem. But this said, okay, we want you to be aware the fact that if you put everything, you collapse everything in one place, the performance might be optimal. But this depends on your network, on the number of flows. You know, it's hard to estimate.
Well, in fact, we are splitting the flow information in different end probes. This is divided. I mean, this hard work is divided. We're using the same Ntopng place to view the information, and it wasn't a problem. I mean, we are not suffering from a performance hit. It's okay. Okay, then we understood it correctly. Thank you very much.
You're welcome. Other questions live? Otherwise, we go through the list of questions on the chat.
What are the requirements? Hello, Oliver from GSI Germany. What are the requirements for using the asset management tool since mine keeps empty?
It's empty. So you mean that nothing is collected there?
Yeah, nothing is displayed when I go to a host and then asset in inventory. It's completely empty. And I collect S-flow information.
You collect this flow. Theoretically, it should not be empty. So this looks like a problem. So if there is a problem, there's not a license issue. Can you please contact us in private so you can display us the bug?
In Discord.
As a bug, because basically you should be able also with S-flow that it is limited the invisibility because it is using sample traffic. You should be able to see that. What versions are you using of Ntopng? 6.4?
6.5 is my testing
6.5.
version. 6.5 and
I have a question. Did you configure the local networks? So do you see local hosts?
Yes. As far as I know, the local networks, and then I put it in the command line configuration, the local networks. Yeah.
Because in the asset we store only local hosts. So you see some hosts that are marked as local with an L, a green L, right?
No, there's nothing. No NL.
You want to show your screen? So you want to...
Can I? Okay. Wait.
Matteo, can you disable screen sharing, please?
Yes, sorry.
Can I? Where is the button to share? Not so familiar with it.
At the top.
Maybe I need to enable you. Just a second.
So other possibilities, and then there kind of to raise hand per persons. Ask question.
No. Alfredo will give you.
Now the share button is okay.
Ntopng device host in local and remote. Okay,
so this is mine.
You have a local host. 65,000. Yes, you have local host.
Yeah, it claims also. I think I have to go for the XL or version. It claims sometimes here that I have too many hosts, but here see remaining hosts. When I click on host, there are some listed. These are the external because it's my router external from the firewall. So it has a lot of creepy traffic. Which is hopefully avoided by the firewall. But if I click here on asset, it remains empty.
No, this is something we need to look at. So if you can send us a message after this call, we can come back to you and
thank
check.
you.
There's something wrong.
Okay. And this the other feature, this network, to define the DNS servers and so on. Is that how is this configured? And
the network configuration.
Where's the basic on policies and then network configuration?
Yeah, exactly.
And then but for me on mine it's displayed the unexpected gateway server checks are disabled. You have to what do I have to enable before?
You can even click on the cog. It should jump directly to the checks. However, you have to enable the unexpected alerts. For example, unexpected DNS server, unexpected DHCP server. So in that way, whenever we see a server that is not part of that configuration you put, we are going to trigger an alert.
Okay. So how do I? What is the basic the requirements for this?
Click there.
There. Okay.
No, on the cog, yes.
And then.
And then search script, and there is a search form. Right.
Yeah.
No. Top right. Yeah, up above.
Right.
Search. Right. Type unexpected annex.
Unexpected. So these are only the unexpected ones.
Yeah. Enable one of these. Enable for the first one.
Unexpected DNS. Let's say.
Yeah. Click on the red.
Oops.
Okay, now go back.
Unexpected.
Yeah, now go back to the config page, the first configuration page.
And now the traffic network configuration here. Okay, yes. Now I can do something.
Okay. Before you move, here you have to specify the core services of your network, saying that I allow only to talk with this. Okay, in case I talk with another DNS, I want to have an error. If you go back at the menu, there is a home button, sorry, a home icon, and then policies. Can you click on policies?
Policies
no. Stay on this page. Yeah. Inside this page, right? Go policies.
Here, policies. Okay.
Okay, this is a little bit different. It requires another check to be enabled. Okay, basically it allows you to specify a core host, for instance, the router or the switch or the main mail server, something like that, that need to be accessed by only some specific host. So for instance, for management purposes, okay? So one of the first problems you see on a network is reconnaissance. So an attacker is moving inside the network trying to find the targets, right? So this is a good way of finding those hosts because you specify that the core host, for instance, the router, the switch, the VPN server, can be accessed only by certain hosts. If somebody else is contacting them, then this is an alert. Okay, this requires another check to be enabled.
Okay, so only the administrator's IPs or the IP addresses from the administrators should be entered here, and then the other one are claimed as
because the router is used to go to the internet, but is not used to connect to the router. So you use not for SSH to the router. So if you specify the IP address of the router,
and for this I have also to enable something.
Yes.
Which is the right to enable?
Yes, it says policy, and search policy.
Policy
host policy, the default,
policy.
the default.
Okay. Yeah. Okay.
And now go
this
back
one,
to
and now back to network configuration and policies. Okay, now I can.
Yeah.
Put
in. You can specify also whitelist host.
So these are the not the IPs of the core router itself. No, it's the allowed or the expected IPs which are connecting them.
Yeah, the core host. So those hosts, yes, and then you can, of course, put a whitelist. So for instance, it's not supposed to talk to the internet except some whitelisted host. This is another problem, because in this case, for instance, a router can connect, it's a secret, let's say, can connect to a Cisco server, for instance, but cannot be, cannot surf the internet, go and do other type of things. This is the idea.
So, but again, here I have to put the devices. All right, the monitor devices, and here the whitelist, the expected ones who
if you have a whitelist, yes.
Okay.
Yes. Exactly.
Okay. And is it an issue about the performance then with activating these features? So the system will increase the performance. So from the server itself, the Ntop server. What is are there limitations? From cores or so, I think 8 cores or so. That's enough.
No. Yes. I don't think it's a problem. It will not put extra load. It is just enable and disable just because we want to avoid the triggering alerts that people don't use that are disturbing them. No. This is not a problem, I would say.
Okay. Good. And how are the alerts? Are they here and on top displayed then under alerts?
No, yes, host alert. Yes.
There will be a new button then with host alerts.
Yes, there's no button because you have no host alerts here.
Okay.
Otherwise, you go to the left menu bar, you click on alerts. If you have alerts, and you will see that.
I have a lot of this alerted flows because of this outside the firewall. Yeah.
You can disable some of them if they're not a problem for you.
Yeah. Inside here or
yeah, for instance, let's have a look at this first flow. Click on the first column, action, under actions.
Action.
Below the first line of the table, left.
Okay.
Let's see what's the problem here. Okay, see, local to remote, for instance, elephant flow. Elephant flow means that you're moving a huge file, okay, 54 gig. Okay, so is this expected or unexpected? This looks like a VPN, right? So it's probably expected, I would say.
Should be to our VPN server, just as our.
Okay, so you can disable that. So you can go inside the elephant flow line below. Go in the middle. Elephant flow. Go right.
Here.
Go right. Go right under actions. Okay. Now put there's not there. Left. No. The yellow one. The yellow one.
The yellow one. Okay.
Okay. It says, what do you want to disable for the VPN? I would say, right?
Okay.
For the client or for the server, I don't know which one it is. So I would say for the VPN.
This is our VPN server. Yeah.
Okay, so you can exclude, and then new alerts will be excluded. So you don't have this anymore.
Only from this server or from all?
No, for more, if you click on any host, if you want to disable the check, I think
so-
you want to disable for the VPN, you said,
So
right?
any host to this one. No, any.
No. Any host means you disable completely elephant flow, right? So if you click on client only for the client host, or the server only for the server host.
But the server, so for all others which are connecting this server, it's
yes.
also okay,
yes.
and then I can go and exclude. Okay.
Can exclude, and this for new
okay,
others,
but
right?
so we went down to from 700 to 400 now. Yeah. Okay.
And the same, this goes triage, so you can go to other type of host.
That's
I don't know what protocol is this.
IPsec.NET. That's VPN. Yeah, so these are one. What is this? A guess? Yeah, that's an unknown port. I think that's why it's claimed.
Guess because you're using S-Flow. Okay, there is no chance to do DPI. So therefore, based on the port, we try to figure out what is the protocol. So I don't know what this protocol is about.
That's some scientific port there, scientific traffic exchange. So it's a well-known port to us. So this is X. So what is this? Xroute protocol for between CERN and GSI and other institutes. This is a well-known port to us.
So you would like to define as a protocol?
Yeah. So I can go this, but this is now the end-of-run flow. Okay, only.
Yeah, this for another one. Or you can completely disable the check if you want.
But this is then all end-of-run flow, or
yes,
only this one? Okay, so all
everybody.
flow.
Otherwise, you can specify a certain host.
Yeah. And then exclude. Okay, it's not going down.
Yes, no, this flow is already there. So for new flows, it will be disabled.
Okay. So it should then go down. Okay, then I know how to proceed a little here.
Yeah, you have to do this triage. So if you want, probably today is not the right day, but if you want, we can make a session, okay, with some of you who are interested to show you how to do that.
Yeah,
that's not a problem.
Yeah, that would be great.
Let me stop. Don't move out of this window. So if you go on the table, okay, at the right side there is input interface, output interface. They are set to 0 to a number 31, 32. So this means that you have not configured SNMP. So if you configure SNMP and let SNMP poll your router L301 GSIDE, it shows you the interface name. So something else I suggest you to do is to configure SNMP.
Yeah.
So if you want to configure SNMP, you go to monitoring to the left menu bar.
In how far configuring? Because SNMP I have activated. So I'm asking a lot of switches and our routers.
But not for this one, probably.
For
SNMP?
No, this one is there. So we are here with the. Well, that's this one here. Okay, but it's a management interface of this one. Yeah.
That's the problem.
Yeah. Okay, I see.
That's the problem.
Because I'm not asking inline interfaces. I'm asking the management interfaces of the devices by SNMP. So that's why
we
it's
need to add an alias. Let me take a note that we can probably implement it. So in essence, you're polling the management interface, but the flows are received from another interface.
Exactly. Yeah. So yeah, they are sent by the 10001, for example, and this is the management interface of the same device.
Okay, this will add it's easy. Anything else you want to ask us?
Maybe I also want to give others a chance to ask questions.
Okay.
Thank you for the information.
You're welcome. Are there other questions, live questions before we go to the list? Okay, let's start with the questions on the chat. Okay, beside the connectivity issues, I apologize that we've seen. And Joy is asking, how long can you go back in history with the embedded database? Okay, history of what? Of alerts, I believe, right? The retention is specified in preferences. So when you go inside the preferences menu, you can specify the retention time. Of course, the embedded database is based on SQLite, that is not super performant. So beside the problem of time, so number of days, you also have to consider the number of alerts that you can store. So if you're talking 10 of 1,000, 100,000, it's already a big limit, but it's feasible. If you're talking about more, I suggest you to enable ClickHouse. ClickHouse can be enabled simply installing ClickHouse on the host and adding to the command line -f uppercase ClickHouse, and it will connect to it. And even with ClickHouse, the story is the same, but with ClickHouse you can handle billion, tens of billion of even more of events. Okay, and you can specify again in the preferences the retention time, so that when you have passed the retention time, let's say 1 week, okay, all the events will be discarded. And then it will be a matter of space and memory, okay, used by the database, but it's not a limitation of Ntopng. Okay, let me go back to the questions. Audio quality. Is the browsing history flow being saved in any dump file? No. So browsing is a local concept. So we don't dump that. I mean, it's the history of the browser. What else? How long we configure back history? I mean, for history, we rely on disk. Okay, for live we rely on memory. So memory and disk are not really related. Okay, everyone, I'm looking on Ntopng retaining traffic for 14 days. Okay. So Emmanuel is asking this question for 14 days retention. In order to set the retention, you have to specify a retention time in the preferences. So it's not that you have to specify the data ID or dump flows. These are just preferences for deciding where to store data, I mean on what path. But for how long, okay, this is based on the retention time you specify in preferences. About this, yes, I think we are good. Any more questions? Some of you want to ask questions, so see some new features live. I would like to ask one question to the audience. Do you think those webinars are useful? Should we do them more often and more focused on specific arguments instead of being general? What's your idea?
I would say yes. It's useful, and we see some features which we might have missed before. Like now, I didn't even know about the asset inventory, and I'm having the same issue as Oliver, so I'll be reaching out to check it as well.
Okay, thank you, Bruno. Makes sense. So we'll make them from time to time. Yeah, we have decided to make this webinar because we have noticed that not all of the users know our tools deep enough. Thank you. Any other comment?
Maybe you can record it too and reach it out later to others that don't have time on this time slot that you make the webinars. But else very useful, and yeah, more deeply in 1 or 2 topics or something like that would be great.
So you suggest us to schedule another webinar, let's say in a month or 2, on a very focused set of topics, 2 or 3 topics, not more.
Yeah, one topic by one webinar, and then you have a recording of that, and then afterwards, if times are in a holiday or something like that, then they can look that up afterwards and so on.
Okay. Anyway, the webinar today will be recorded. Actually, it's recorded, and we'll share the webinar, of course.
Thank you for your presentation. I really liked the first part, and I would think that it could be easily like double the time spent on the topic, because it's quite new for me and it was quite fast, and I would like to spend more time to just get to know the framework.
Okay, that is possible. So you're saying that you would like to go more slowly, okay, into Ntopng and show a better introduction to how to use the tool. This is what you're saying?
Yeah, you could have easily extended it more. Like I would like to spend the time. I think you wanted to be efficient, but to my mind, it's not even necessary.
Okay, so if you want, in 2 weeks we have the NDPI webinar. So probably later in June, we can make another Ntopng webinar and go only in live mode. So this is what you're asking?
Yeah, sounds good.
Okay, we'll keep a note. Take a note. Okay, there's one question in the chat. How can you use this data after some time? Okay, so the question is there's a picture on the chat. Okay, this is a live flows view. Live flows means that the flow stays in memory as long as the flow is active. Okay, when the flow is over, the flow disappears. So in order to keep flows in memory longer, what you have to do is you have to enable historical flows. Let me show you something. I'm gonna show you a demo. Okay, as soon as you can see my screen, right? So if you want to keep flows for a longer period of time, you have to enable ClickHouse, the database. When you enable ClickHouse, you will see here historical. There is a new entry under flows. You see historical flows. Okay? If you click on historical, you can see the flows that have been saved on disk, okay, onto the database. And as I've said before, this allows you to query data, okay, and allows you also to create on demand a new interface here that contains the extracted information. So let's say if you want to create in memory a new interface that contains the last 30 minutes of flows, you can create here. You can click here. There is a play button. You analyze the traffic, and there is a new interface you see called database that contains those flows. Okay. Now, how can you set the retention time? That the question was asked before. You go to preferences here. ClickHouse. Okay, and you can oh sorry, this is not the wrong interface. You can enable the data retention. That's by default is 1 month, but you can specify longer or less. It's a matter of this space. Okay, and of course, the more data, the more space. Okay, that's the only thing I'm saying. Done that, you can go back in historical. And you can see what is happening. So if you have data from, let's say, yesterday, you can see in data of yesterday. See what I mean? And as you can see, it is pretty fast. Okay, the performance is very good. This is a very low-end machine, but as you can see, it's almost immediate. Okay, you can of course click click on the protocol here. You can specify, okay, show me only the flows with WireGuard, let's say, or show me only the flows with RPI3. This is very simple. And when you're happy, you can go here. If you want, you can create a new interface only with those flows. But the retention is specified based on the duration that is specified in the preferences. That's how long the data should stay in the database. Whereas live flows, let's go back to live flows here, they stay in memory as long as the flow is active. So when the flow here, okay, is no longer updated, okay, so when there is no traffic for some time, then the flow is purged from memory. It is removed from memory. But it is stored into the database. So you can look at the flows into the database. And you see there are icons here and there. So if you click here, plus you can go to database and see, okay, for this host, who has done what in the past. And everything is included. For instance, also the quality of experience, the quality, okay, the cybersecurity score, everything is there. So when you have historical flows, in essence, you have the same view as you have in the live interface. Thank you very much, everybody. I hope you enjoyed this time, and I hope to see you in 2 weeks. Okay. Thank you. Bye-bye.
Thank you all.
Thank you
very
very
much.
much. Thank you.
Bye.
Bye.